So in our last video, we looked at how the slope and the y-intercept kind of work together to define the appearance of a line. Change the slope, change the y-intercept, change them both, you'll get a line that looks different somehow. So we're going to focus right now on this line, y equals 1/2 x plus 3, only this time I don't have the graph of it. In fact, I want to make a more exact graph if we can. And so to do that, we're going to try and come up with some ordered pairs, x, comma, y. And in fact, I want to come up with two ordered pairs. Each of those would be a point on the graph, okay? Because I only need 2 points that lie on this graph to draw the line of that graph. There's only one line that would go through any 2 points, as we'll see in a little bit. All right, to find those ordered pairs, those xy pairs, what we're going to use is an xy table. And what we do is just pick a value of x that we might want to plug into our equation here. I'm going to choose the value 4 to start. And so I'm going to say x is 4, which means I'll come over here and plug in the value of 4 for x. Now, half of x, half of 4 is 2. Add 3 to that, we get 5. So our value for y is 5 when x is 4. That's an ordered pair. You can write it down here. It's the same as we see it in the table up above. Let's choose one more value. This time let's go negative. Let's make it -2. And if we plug in, not 4 this time, but if we plug in -2 into that formula, half of -2 is -1. Add 3 to that, we get 2. So that gives us one more ordered pair to plot on our grid over here. So we'll come over here and we'll go to 4 over and 5 up, put a point right about there. And then we'll come to -2 over and 2 up. That would be in our second quadrant here. And those 2 points will define the graph of this line. Go ahead, pick any 2 points, put them on a piece of paper, and try to draw more than one line through those 2 points. Can't be done, right? A line by definition is straight, and the only line that goes through these 2 points would be this line. Similar here, there's only one line that goes through these 2 points. It's going to look like that, and it's going to define or be the appearance of our graph defined by this line here. All right, the key takeaway from this is that to know what the graph looks like for any line, we only need to know 2 points. Similarly, if we have 2 points of the graph, we can determine what its equation would be if we didn't know it. And that's going to be our goal for this section.